Hi Algebra, today we're going to be doing the Topic 9 Quarter 3 test review. So this very first part, this is 9-1A. Remember, this is factoring by taking out the GCF, meaning after you take out the GCF and there's nothing else you can do, you just leave it as is. You don't have to continue factoring as you would the rest of the sections. So for these first four, I am identifying the GCF and that's it. I don't need to put the remainder or actually factor it. I'm just finding the GCF. So I want to start by looking at my numbers here. I have 14 and 21, or you can think of it as negative 21. The biggest number that multiplies into both of those numbers is 7. Then I have y squared, and you can think of this as y to the power of 0 over there. There's no y. Since only one of my terms has a variable, I cannot take out another variable. So that means that my GCF is just 7. Now over here, the first thing that should stick out to you is no matter what, if the very first term, of course after it's in standard form, is negative, no matter what, you have to take out a negative GCF. So if I have 3 and 7 as my numbers, or negative 3 and 7, there's no number that multiplies into both of those other than 1. But since I have a negative 3 in front, I want to take out a GCF of negative 1. And again, since only one of my terms has a variable, I cannot take out a variable as my GCF. Okay, this one, same idea. I have 10 and 18. The greatest number that multiplies into both of those is 2. Now I want to look at my variables. I have r cubed and r squared. Both of my terms have a variable, so I know I'm able to take a variable out, but the greatest amount of variable that each term has is r squared. One of them is r cubed, the other one does not, so I can only take out r squared. So that means my GCF is 2r squared. All right, lastly, same idea. I'm going to look at my numbers first. I have 4, 16, 22. The first term is positive, so my GCF is not going to be negative, but the greatest number that multiplies into all three of those is going to be 2. Even though 4 multiplies into the first two, it has to go into all three of them. So that means the greatest number is 2. Then I'm going to do the same thing with my variables. I have n cubed, n squared, and the greatest amount of that variable in all three terms is just n, so my answer is 2n. Okay, so for these next two, I actually am going to factor out the GCF, but remember the very first step is it has to be in standard form. Up here, it was already in standard form, so we didn't have to worry about it, but this one right here, standard form tells me that I have to have the greatest exponent first, and then it continues on in descending order as it moves to the right. So I want to rewrite this as negative, that is way too bold, okay, negative 42x cubed minus 14x squared plus 7x. Okay, it's already in standard form now. That's our first step. Now I want to look at my three numbers. I have negative 42, 14, 7. Remember that first term is negative, so I know I have to take out a negative GCF. The greatest number that multiplies into all three of those is 7. So I'm starting with negative 7. Now I can look at my variables. I have x cubed, x squared, x. The greatest amount that goes into all three is just x. So that means my GCF is negative 7x. Now I'm able to look at my remainder. That means you're going to divide each term by the GCF. So negative 42x cubed divided by negative 7x will give me a positive 6x squared. Then same thing for my second term, which will give me plus 2x. Same thing for my last term, which will give me minus 1. If you notice, the terms change signs because I took out that negative. Same idea over here. Since there's multiple variables, I don't have to worry about standard form or anything. I'm just going to leave it as is. My greatest exponent is 6, so I can just leave that in front. Okay, I'm going to start by looking at my numbers again. I have 36, 40, 28. The greatest number that multiplies into all of those is going to be 4. So I'm going to start by writing that. Now I can look at my variables. I'm going to look at one at a time. I'm going to look at my a's. I have a to the power of 6, a to the power of 4, a to the power of 3. The greatest amount I can take out is a to the power of 3. Now I can look at my b's. I have b to the power of 2 and then b. Only 2 out of my 3 variables have that b, so I cannot take it out as a GCF. So that means my GCF is 4a cubed. Then I want to divide each term by my GCF, and it will give me my remainder. So I will do 36a to the power of 6 divided by 4a to the power of 3. That will give me 9a cubed. Then I'm going to do the same thing for my middle term, which will give me minus 10ab squared. And since I can't take out that b, it just tags along for the ride. And then lastly, plus 7b. Okay, now we're moving on to factoring by grouping. Remember, that is when you have 4 terms, you have to split it into 2 binomials, take out the GCF of each one, then you write your GCFs in one binomial, remainders in another. So I'm going to start by breaking this up into 2 binomials. I'm going to say this is my first one right here, and this is my second one. I want to start by finding the GCF and the remainder of the first binomial. The greatest number I can take out is 2. The greatest variable I can take out is x squared, and my remainder will be 4x plus 3 on the inside. I'm going to do the same thing on the right side. My term, negative 4x, it's negative, even though it's not in the very front of the entire polynomial. That specific binomial we're looking at starts out as negative, so I want to take out a negative 1. Then left over, I will have 4x plus 3. That's your first step. Break it up into 2 binomials. Take out the GCF, write the remainder in the middle. Your remainders should always be the same. They should be twins. You want to write your GCFs, so I could do 2x squared minus 1. Again, this is where we get our GCFs. And then our remainders, again, they should be twins, 4x plus 3. That's where we get that, and then we're done. Moving on, this one, as you can see, hopefully this jumps out to you that it is not in standard form. Your very first step is to put it into standard form. I want to write this as 2x cubed plus 4x squared minus 6x minus 12. Then from here, now I am able to break it up into my 2 binomials. You have to put it in standard form first. The GCF of my first binomial will be 2x squared, and on the inside I will have x plus 2 . Then the GCF of my second one will be negative 6, and on the inside I will have x plus 2. I want to start by writing my GCFs first. So I have 2x squared minus 6. That is my GCF. Then my remainder is x plus 2. And remember, your remainders will always be the same. So that's one way you could do it. We want you guys to show that you take out the GCF first. The main goal is that you always want to take out the GCF first. If I'm going back to this very first part right here, even just looking at it, I can see that every single term is even. Because of that, I can take out a GCF of 2. So if I take out a GCF, and I'm going to do that down here, I would have 2 times x cubed plus 2x squared minus 3x minus 4. Now I'm going to try to solve this by grouping down here. So the first one, we just solved it just assuming there is no GCF. This is why we're going to show that you always want to solve by finding the GCF first. It'll make it easier for you. All right, so I'm going to ignore that GCF for now. The GCF of the first binomial is x squared. Then on the inside, I will have x plus 2. The GCF of the second binomial is -1. Then on the inside, I will have, what did I do wrong? There we go. So sorry. -12 divided by 2 is definitely not -4. Okay, sorry about that. We fixed that. So then I'm able to take out a GCF of -3. Then on the inside, I will get x plus 2. Now I can write my GCFs first, which will give me x squared minus 3. Then I can write my remainder second, which is x plus 2, which I get from right here. And then at the very end, you have to bring that GCF down. It will be right here. This will be your final answer. Make sure you take out the GCF first. Write it like this, the second way right here. Okay, now we're going to move on to factoring. This first one is when a is greater than 1. So when a is greater than 1, you do not have to worry about multiplying the a times c, because if a is 1, then it's always just going to be finding the factors of c. So I'm going to start with -10 and think what multiplies to -10 but adds to 3. That will be 5 and -2. They'll multiply to give me -10, but they will add to give me 3. So I'm going to write this. I'm going to expand this first. And I'm going to write x squared plus, and then instead of 3x, I'm going to do 5x minus 2x minus 10. This part right here became this part right here. We just expanded that. Now I'm able to solve this by grouping. So I'm going to break this up into the two binomials and take out the GCF as we did above. The GCF of the first one is going to be x, and then on the inside, I will have x plus 5, and then the second one will be -2, and on the inside, I will have x plus 5. I'm going to write my GCF first, which is x minus 2. Then I'm going to write my remainder second, which is x plus 5. And I get x minus 2 times x plus 5, which, as you can see, it's the exact same as the factors that we got. When you have a equals 1, you can take these two factors right here and just plug them in straight into the binomials, just when a is 1. However, over here, well, I guess this is different because we're going to take out a GCF. But if it's not a is 1, then you have to expand it first. Okay, so first one, remember this negative right in front? I don't want that. I want that to go away. To do that, I know I'm going to have to take out a GCF of a negative number. I don't know what it is, but just by looking at this, I have a 4, a 44, and a 120. I know that 4 goes into all of those. So I'm going to start by saying a GCF of -4. All three of those terms have an x. So I'm going to say my GCF is -4x. Then on the inside, I will have x squared plus 11x plus 30. Remember, the terms change signs when you take out a negative GCF. Then from there, I am able to find the factors of 30 that will add to give me 11. I know 5 times 6 will give me 30, but will also add to give me 11. So I'm going to rewrite this equation right here, but instead I'm going to write it as x squared plus 5x plus 6x plus 30. And I'm just going to, here, we'll just write that negative 4x right in front. We'll just leave it right there. This part right here just expanded to give me this part. Now I want to take out the GCF of each binomial. My first GCF will just be x, and then on the inside I will have x plus 5. My GCF of the second one will be a positive 6, and on the inside I'll have x plus 5. That means my GCF will be x plus 6, and my remainder will be x plus 5. So my answer is x plus 6 and x plus 5, and I want to bring this GCF back down, so I will have negative 4x. And then, let me make sure I got that. There we go. So one more time, when a is 1, you are able to take your factors and just plug it straight into here. I just want to make sure we got down that factoring by grouping part, because when a is greater than 1, you're not able to just plug it straight in. All right, so this is a dots method. Difference of squares. Difference of perfect squares. Okay, so dots, think of it as it starts small and it ends up big. I'm going to end up with 2 binomials when it's a dots problem. I want to start by taking the square root of the first term, the square root of 4x squared. That is going to give me 2x. So I'm going to write a 2x here and a 2x here. Then I'm going to take the square root of the second number. Square root of 49 is going to give me 7. I'm going to write a 7 here and a 7 here. Difference, that means I'm subtracting, but I have to think what factors multiply to give me negative 49, but add to give me 0. That means one has to be positive 7 and negative 7. So that means I have 2x plus 7 and 2x minus 7. That's dots. Starts small, ends up big. PST, that's the opposite. It is going to, oh, give me 1 second. I have a different example on here. Okay, well, I'm going to solve this one like normal. So my very first step, I can see that I have a GCF here. So I'm going to take that out first. I'm going to take out 3. Then on the inside, I will have x squared plus 16. Now your brain might think, oh, this is a dots problem. I cannot make this a dots problem. It is not a difference. I'm adding it. That means this right here cannot be factored anymore. I am done right now. So that, we're done with it just like that. All right, this one, a is greater than 1. That means, first of all, I know I'm going to be factoring by grouping. I have to expand my b term. But before I can do anything, I have to multiply my a times my b, which is 45. I have to think what multiplies to give me 45, yet adds to give me negative 18. That's going to be negative 15 and negative 3. They're going to multiply to give me a positive 45, add to give me a negative 18. So I'm going to rewrite that equation, but instead I'm going to have 5x squared minus 15x minus 3x plus 9. This middle term right here, we just expanded to this, same way we did before. Now I'm going to take the GCF of each binomial. GCF of the first one will be 5x. Then on the inside, I will have x minus 3. The GCF of the second one will be negative 3. And on the inside, I will have x minus 3. I want to start by writing my GCF first. So I have 5x minus 3 in one binomial. Then my remainder, which is going to be x minus 3. Whoops. Okay, there we go. And then that's my answer. I can leave it just like that. The best method, this one is just going to be factoring, or factoring by grouping. All right, this one over here. Remember your first step for all of this. Take out a GCF first. Same way we did it up here. I am going to take 5 out from both. So my GCF is going to be 5. Then on the inside, I have x squared minus 10. There's no numbers that multiply to give me negative 10, but add to give me 0. The only time that can happen is if it's the same number, different signs. And 10 is not a perfect square, so I cannot factor this anymore, and I'm done just like this. It is not a dots problem. It looks like it, but it is not, because it's not, 10 is not a perfect square. That means best method is GCF. Sometimes you're going to have answers that look like this. All right, and then that is it.